Let's talk about section 10.6. 10.6 talks about circles and proportions. I had kind of started talking to you about these yesterday. I drew these pictures up here. We talked about we're going to have secants that intersect inside the circle and gives us a special relationship. We have secants that intersect outside of the circle. And then we also are going to have, when we have a secant and a tangent intersect outside the circle. So you see I have three different things written up here. These are our three basic formulas of three types of problems we're going to have. So we're going to have when they intersect inside, what it's saying is the product of each part of one secant is going to be equal to the product of each part of the second secant. So I can take the A times the B, and that's going to be equal to the C times the D. Okay, so we can write that as a problem, and then we can solve it for one of the pieces of the secant that might be missing. Now, when they intersect outside the circle, you have same kind of concept, except since it's outside, it's the entire secant to that point. The A plus B times the part that's on the outside. And then the entire part down here, C plus D, times the part that was on the outside. Okay, so on these, you have the entire thing times the piece that was outside of the circle. And then here you have the entire thing, C plus D, times the D, the piece that was outside the circle. So we got this formula when they're intersecting inside. We have this formula when it's the two secants that intersect outside. And then we have this one down here where we have a tangent and a secant. So when we have the tangent and the secant, you have the tangent squared, multiplied it by itself, because that's the only one measurement that you have. And then you have the entire secant segment times the piece that was outside, similar to what we had up here. Okay, so those two are pretty similar. So we have three different types of problems that we're going to be dealing with these. Okay, now our first ones on number 1, all it's asking us to do is just write the relationship. So it's going to be looking at the picture, how they labeled the parts of the secants or the tangent, the secants, and writing the expression that follows the rule looking at one of these. Okay, so we're just going to take the picture, match it up to one of these three, and then use that as our guide to write the equation, proportion, relationship, whatever you want to call it. Okay, so we're on page 559. Okay, we're on page, sorry, my nose is like, oh. 559, and we're going to be just doing 1 through 8 of these. Okay, so I've got my 3 rules here that I'm going to be using for number 1, part A, B, and C. I'm going to see which one it looks like and then write the thing. Now, looking at 1A, you should notice that it looks a lot like this one right here. You have the two secants that intersect inside the circle. So you can write your equation or proportion, whatever you want to call it, showing the relationship. Okay, it has an equal sign, so you can call it an equation. So looking at this, we're on page 559. Okay, I should see everybody. Everybody should be with me already and working. Okay, you take the ones that are on the same secant. So A is on the same secant with what letter?
D.
D. So I'll have AD is equal to, and then on my other secant, I have B and C. So I have AD is equal to BC. And that's it. That's all you're doing on number 1, is we're figuring out which one it matches up and then learning how to write our equation. So then when we have to solve for missing parts, we can get them set up correctly, okay? So let's look at number 1, part B, okay? It looks like this one or this one. The middle one or the bottom one, which one is it? It's the middle one. They were going in order, okay? They went in order. So on here for this one, you pick along the same line. Now you'll notice what we did is we took the whole segment first, and then we multiplied it by the part outside. So my whole segment on the top is V plus W. That secant on the top would be V plus W. And then I multiply that by the piece outside, which is the W. And then I do the same for the secant on the bottom. The entire secant on the bottom is T plus U. That was outside is what? Okay. Is everybody with me? Yes? No?
No, I can't see.
Okay. Let's see.
It's
The Wi-Fi's acting up. I know earlier it looks like my little signal thing's lower, so it's trying to be difficult today. We'll try to get through best we can. All right. So number 1 looked like this picture. So we wrote our equation based on this picture. Number 1 part B looked like this picture. So we wrote our equation based on this one. Part C is then going to be like this one on the bottom. So we're going to write our equation like it has there. So on that one, remember, the tangent is the one that's out here just by itself. So my tangent is the x squared. I always put the tangent one first, so it doesn't matter, because you can switch what's on either side of your equal sign. Okay, you can switch what's on either side of your equal sign and it still be equal. That's the reflexive property. Okay, so I have x squared equals, and then for the other part here, we're going to do like we did here. You take the entire secant times the piece of the secant that's outside. So the entire secant is y plus z on the top. And then the piece of the secant that was outside of the circle was the y. So all we were doing on those is learning how to write our 3 different types of equations that we're going to use. Okay? Now I know people are having internet issues, whatever, so just, well, try to do the best we can. Okay? For those of you that are logged on, I should see you. Okay? Except Michael, I know what your problem is, but the rest of you, I should see you on here. Okay? Not just your wall, you. All right. Number 2. Now on number 2, 3, and 4, we are using these relationships that we just learned, and we're going to have to solve for a missing piece of the secant or tangent. We're going to have to do work. Okay? So looking at number 2, it says find the value of the variable. That picture looks like the first one here. Okay, it's the secants intersecting on the inside. So since it's intersecting on the inside, we can write our proportion. Not our proportion, our equation. So I'm going to do this one that's going up and down first. So I have 2 times 6 is equal to 3 times x. Okay, stuff that's on one secant goes together, stuff that's on the other secant goes together. So this part times the other part, and then 3 times the x goes together. Now I just put the 3 first because you always put the number in the front if you have a number in a variable. So then we just solve this. Hopefully everybody knows that 2 times 6 is 12.
Well,
12 equal to 3x. I'm trying to get x by itself to find my missing part. We divide by 3. You get x is 4 and you're done. Okay? So these aren't that difficult. It's just making sure you look at your examples and get it set up correct. Okay? Now number 3, if you look at number 3, it's got the 2 secants that are intersecting outside. So it's like this one. You have the 2 parts of the big secant going up and down, and then you got the 2 parts of the secant going across the bottom. So we're going to use something similar to this one. So remember, you have the total secant times the piece outside is equal to the total secant times the piece outside. So I'm going to start with this secant first. Okay, this secant on the right-hand side first. So I have 5 plus 3, which hopefully everybody knows is what? Okay, and that's going to be times the 3 that was on the outside, right? Now for the other one, I've got y plus 4, okay, because that's my 2 pieces of my secant, and then it's times the 4 that was on the outside. So this one you have to do a little bit more work because we end up having to use the distributive property, okay? But we already said, hopefully you knew 5 plus 3 was 8. So 8 times 3, you got 24 here. We're good with that part. Over here, I can't add y and 4 together. So I'm going to have to use distributive property. I got to multiply 4 times each thing in there. So 4 times y is 4y. 4 times 4 is 16. Now, anytime we have an equation, our goal is to get the variable by itself. So I'm focused on getting y by itself, so I have to get the y term by itself. So to get the y term by itself, I have to get rid of the plus 16 first. You do the inverse or opposite operation, so I subtract 16. Whatever I do on one side of the equation, I do to the other. 24 minus 16 is 8. So I have 8 is equal to 4y. Y is still not by itself. Divide by 4. So 2 is equal to y. So that means that little piece of my segment on the secant at the bottom was a 2. Now for number 4's picture is like this one. Number 4's picture is like this one. We have a tangent and we have a secant. So I always do my tangent part first. So my tangent part is the 12 up here on the top. So I have 12 squared. I'll skip the camera over in a minute so you can see the equation. And then on the bottom, I do the secant part. Now the secant part for this is similar to what we just did here on number 3. You have the 2 pieces added together, so 9 plus z, times the piece that was outside of the circle, which was the 9. Okay? I know, it flashed up, my internet was unstable again, so just try to hang in as best we can. Hopefully we can get through here. So this is what I have so far on this one. So on number 4, we're going to square first. 12 squared, 144. And then here I have to use the distributive property again. 9 times 9 is 81. 9 times z is 9z. Just like what I talked about on number 3, our goal is still to get the variable by itself. This time it's a z I'm trying to get by itself. I got to get rid of the 81 first. It is a positive 81. So to move it to the other side, I subtract 81 from both sides. So 144 minus 81. I got 63. Hopefully y'all agree with me. Some of you were trying to answer, but with the internet, I think it's Don't let me come through. So we had 63. Z is not by itself yet, so we divide by 9. That cancels, so I have Z equals, and then 63 divided by 9 is 7. So I found my Z part was 7. Okay? So these shouldn't actually be that hard. It's just making sure we use the correct example to set it up by. Okay? Now, number 5 is not doing any math work. Number 5, we're just filling in a bunch of blanks. Okay? Using these things we've been talking about. It says, complete the following statement summarizing the 3 theorems of this section. So our 3 theorems were that when 2 secants intersect inside, the product of the secant segments of one is equal to the product of the secant segments of the other. Blah, blah. You had all those theorems there on your notes, plus in the book in the green boxes. Okay, this is summarizing them here. So remember, on all of these, we were multiplying stuff. So our word for multiplication is product. So the product of the lengths of the 2 segments from a point to a circle is constant along any lines drawn through the point and circle if the length of a tangent segment is listed as 2 factors. So those are the words in the order that they go in the blank. Okay? The product from the point to the circle of one is equal to the product of the point and the circle of the other one. Which that's what we've been doing on these. We've been figuring out what product, what things we can multiply together on here. So everybody getting their words down for number 5?
I got mine.
All right. Now on number 6, 7, and 8, we're going to be doing the same stuff that we did on 2, 3, and 4. It's just they don't already have the picture labeled. They give you the measurements, and you got to make sure you put them in the right spot. Okay? So we got to label the stuff on our pictures. Now you have the picture there in your book, so it's easier for you to label them. I have to try to draw them up here, and you know I can't draw circles. So here's my circle for number 6. I have secant going down here, secant going here. This is D, C, B, A, E is in the middle. Okay? So that's what it gave me. Now in number 6, it says that we're looking for EC. So EC right here, I'm going to put a little X because that's not what I'm looking for. That's my variable. Okay, that's what I'm trying to find. If DB is equal to 6, so this whole chord, the whole thing is 6. Okay, the whole thing is 6. EB is equal to 1, so just this piece is 1. And AE from here to here is 2. Now, what we have to remember is when we were talking about when they are crossing inside, did we use the whole secant segment?
No.
No. We didn't have the stuff added together like we did on these. Okay? We didn't add them together. We did each part times part equals part times part. So I have to find my part on here. Now, it told me the whole thing was 6 though, and if this little piece is 1, that means this piece up here is 6 minus 1 or 5.
Nope.
Right? Because 6 minus 1 is 5. So now we're ready to actually set up our equation and solve it. So when I'm multiplying these from A and C, I have 2 times X. And then that's equal to multiplying on D and B, which is 5 times 1, which is
Just
Because, I mean, if you want, I'll still write 5 times 1, but you know it's 5. Okay? Now, your goal is to get the x by itself now, so all I have to do is divide by 2. And you can get a decimal. So 5 divided by 2 is
5 divided by
2.
4 point something.
2.5. Okay. All right. Everybody finish in number 6. I'm going to be trying to draw my circle for number 7. Because I told you all I hate drawing this. Okay. So number 7 has the one little secant down here, and the bigger secant going up that way. Okay, this is N, M, L, K, J. All right. So for number 7, I've got my picture drawn. We have to read what it gave us. We're finding MN. So MN is right there, so that's my X. And it says LM is equal to 8. So that's this little piece out here. LK is equal to 10. That's that little piece right there. And LJ from here all the way to here was 26. Okay, so this is what we got. Now remember on this one, it's the secants intersecting outside. So this is like what we did on number 3. You're going to have the sum of the whole thing times the piece outside is equal to the sum of the whole thing times the piece outside. So my sum of the whole thing up here is the x plus 8, right? The two parts added together. Sum of the whole thing. So I have x plus 8 times 8 for my top secant. On the bottom secant, I have the sum of the whole thing, which it gave it to me was 26, times the piece that was on the outside, 10. So they had already gave you the total, so we didn't have to add it together on the bottom secant. So we're ready to solve when you're getting to this point. I'm going to scoot y'all over a little bit more. Okay, so hopefully you can see it up there. You got to use the distributive property first. So 8 times 8 is 8x. 8 times 8 is 64. And then 26 times 10 is 260. Now, from here, our goal is to get x by itself. So I get rid of addition first by subtracting 64 on each side. And so I have 8x equals, and then I'm going to take 260 minus 64. I get 196. And then I'm still trying to get x by itself. I have an 8 in front of it. So I divide both sides by 8. And I have 24.5. Okay. Last one of these, number 8. Draw my lovely little circle. Yeah, that's pretty. All right. I can't look at that. That's terrible. All right. Let's try again. Draw my lovely little circle. I'll draw it smaller. I'll do better. All right. So on number 8, we have a secant coming out, and then it's got a tangent down at the bottom. Okay. This is y. This is z. This is x. This is w. Okay. So in number 8, it tells us find yx. Yx is this piece here. So I'm going to use a different variable just because I got an x right there so it doesn't confuse you. I'm going to use a this time just because with the x there, I don't want it to confuse you. So we're looking for that. Wx is equal to 5. and YZ is equal to 6. Okay, now remember, this is going to be like what we did on number 4. When you have the tangent part outside, you have the tangent squared is equal to the sum of the secant parts times the outside secant. Okay, so I have to do my sum of my secant parts up here is the a plus 5. Okay, so now I'm ready to try to do my equation. So I have the whole thing, a plus 5, times the piece outside, which is my a, is equal to my tangent part squared. Okay, now remember I told you it doesn't matter which side of the equal sign you put which part on. I just put this one on the left because that's where my variable was. Okay, because usually you all like having the variable on the left when you're solving the equation. Now, on here we got to start by doing our parentheses, disappearing by distributive. So a times a is a squared. A times 5 is 5a. And that's equal to 6 squared, which is 36. Now on this one, I can't simply just add or subtract to get a by itself because I have an a squared and an a. So we got to do a little bit more work on here. It's a quadratic equation. So we can still solve this. We've done it before. You have to get everything over on the one side. So to move the 36 over here with the other stuff, it's positive, so I'm going to subtract it. So I have a squared plus 5a minus 36 is equal to 0. Okay? Now, the reason that I moved it over here is because we solve quadratic equations by factoring. So we look for things that multiply to equal 36 that will subtract, since this is a minus sign, to equal 5. So things that multiply to equal 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Okay, so I'm going to pick the pair of those that will subtract to equal 5. So I'm going to use the 4 and the 9. So I have parentheses, a, 4, and 9. It's a positive 5 in the middle, so the bigger one of these numbers has to have the plus sign in front of it. The other one has the minus. And then I set each factor equal to 0. So I have a minus 4 equals 0, and I solve to get a by itself, so a could be 4. Then I've got a plus 9 equals 0, and I solve to get a by itself, and I get a as negative 9. Now the thing is you have to think about what we were finding. We were finding the length of a segment, a part of the secant. So if I'm finding the length of something, can you measure the length of something as a negative number?
No.
No, you can't have a negative length, okay? Your arm's not negative 2 feet long, okay? You can't have a negative length. So that one doesn't work. Your other one has to be your answer. So A will be 4. Okay? So that was our circles and proportions. Okay? So that part hopefully was fairly, they weren't too bad, I don't think. I hope not. Okay? Let's see. Page. All right. So, in your book, turn the page, and I want you to look at, well, it's a lot of pages. Turn to section 11:7. So you got Mona Lisa on there. Okay. Page 564, section 11:7, where you see Mona Lisa. Okay. I just want to talk about what the concept of golden ratio is. Okay. We're not going to do a lot of work with this or anything. I just want you to understand what it is. Okay. So The golden ratio is defined as the ratio of a whole segment to its greater division when that ratio is the same as the ratio of the greater division to the lesser division. So that sounds really confusing, okay? But the main thing you need to know is that the golden ratio is an irrational number like pi. So it goes on forever, okay? It doesn't end. The golden ratio goes on forever, it doesn't end, okay? It's the length to width ratio, and it usually is used like pi, we usually use 3.14. Your golden ratio, they usually use 1.618. Now they use a symbol for your golden ratio, the Greek letter phi, okay? The Greek letter phi looks like this, okay? And it's approximately 1.618. So when they're talking about the golden ratio is used a lot in art because it's what's appeasing to the eye. Okay, it's just a good proportion. Okay, if things are following the golden ratio, it's a good proportion. That's what they were talking about on Mona Lisa, about like from her forehead and then from her nose down. It has that ratio. Okay, it talks about the golden rectangle. That is used a lot in building and stuff because it is appealing to the eye. It's that it has that ratio and makes it more appealing. It's just what draws us to it. Okay. Now, what we're going to do is we're only going to do 3 of these where we're trying to see if they are golden rectangles. If it's a golden rectangle, that means it has the golden ratio. Now, what did I tell you the golden ratio was? This right here, approximately 1.618. So all we're going to do is, if you look on page 566, we're going to do them right here, because these are like no work, hardly at all. It gives us 3 rectangles, and we're going to see if they're golden rectangles or not. To see if they're golden rectangles, we do the ratio of the length to the width. That's how we find if they're golden ratio. So on number 1, if you look at your rectangle, the length is 26 millimeters. So 26 goes on top. The width is 15 millimeters. 15 goes on bottom. And then you just divide it. So that's how you see if it's a golden ratio. So 26 divided by 15, you get decimal. I got, let's see, to the nearest hundredth, so I round off, it's 1.73. Okay?
Yep, same thing.
It's close to the golden ratio, but is it the golden ratio? No. Okay, it's close, but it's not there. So we do number 2. Number 2, its length is 36.3. Its width is 22.5. So let's do that one. Whoops. 36.3 divided by 22.5. I got 1.613 repeating. So this one is a lot closer to that golden ratio. So they would go ahead and call this a golden rectangle because it's just a few hundredths off. I mean, a few thousandths off. So they would call that a golden rectangle because it's close to that ratio. Okay. If you'll notice, most of the time on a poster or in your book, if they're just randomly doing rectangles, a lot of times they're more like this rectangle. They're more using that golden ratio, okay, the ones that they draw in the pictures, okay? Number 3, the length is 45. The width is 15. So 45 divided by 15 is just 3. Is that close to that?
No.
No, that's nowhere near close to it. Okay, so that's what it's talking about when it's golden ratio. What is this Greek letter called that they use for that? Pi. Pi.
Yep.
In case you didn't notice, you know, since Greek mathematicians are the ones who discovered a lot of math, they use a lot of Greek symbols in it. Okay, we had a lot of them in Algebra 2. If you've already had Algebra 2, you had a lot of them in there for different symbols. Same thing in here. Okay, so that's golden ratio. Is that part pretty easy?
Yeah.
Yeah. Okay, so I just wanted you to know what the golden ratio was. It's the ratio of length to width, and it's approximately 1.618. Okay, now the only other thing that we are going to try to talk about is the first section of chapter 12, just your basics. Your first section of chapter 12, your basics, is the sine, cosine, and tangent ratios right here, which if you've been filling in your notes, which I asked you to do, okay, and that were in your folder, then you should have that. Okay, your sine, cosine, and tangent. They are used primarily with our right triangles. So everybody remembers our right triangles, correct?
A little bit, yeah.
Hope so.
A little bit.
Right triangle. Okay. That's not pretty, but it's there. Okay. This is A, this is B, this is C. So the two sides that make the right angle are legs. Okay, and the side up here is always our hypotenuse. Now, the way these work is a lot of times they will use just a capital letter for the vertex telling you which angle they're talking about. Okay, so let's say I use this is A, this is B, this is C. Okay, so when you're talking about these, it'll say like the side of A, the side opposite. This is opposite of A. This is next to or adjacent. So you need to understand opposite means across the triangle from it. Adjacent means next to it. Okay? And then the hypotenuse is always the side across from the right angle. Okay, we're just going to cover the basics of those in review tomorrow. And we'll review next week on Tuesday and Wednesday. Now, tomorrow, our schedule's a little bit different. Did you all look at the schedule I emailed you all on Monday afternoon?
Yes, ma'am.
Okay. Tomorrow, we're not actually starting until 11:15. And the reason we're not starting till 11:15 is because you have your biology exam in the morning first. Okay. So I wanted to give you a little extra time if something happened and you took a little longer on your biology exam, or you just needed a little bit more of a mental break before you had to try to switch to geometry, you had a little extra time. So we won't start class tomorrow till 11:15. Okay? And then on Tuesday, you have your grammar exam in the morning, so I won't see you all until 11:15 again to give you that extra little break after your exam. Okay? Wednesday, same thing. I won't see you because some other people have their grammar exam in the morning. Okay? So from tomorrow, the rest of the times I see you, except for next Thursday when you take your exam, instead of being at 11 o'clock, we'll meet at 11:15 tomorrow, Tuesday, and Wednesday. And then your exam is next Thursday at 1 o'clock. And then when you're done with it, you're done and you log off, and that'll be the end of this year. You'll be done. Okay? Now, I've been trying to go through and talk to people what they have missing. Remember, if you're finishing your notes, filling in your notes, just like anything else, you know, send that to me too, pictures of that, so I can give you credit for filling those in. I still have some people who haven't sent me that worksheet that had the different transformations on it. It had translation, reflection, rotation. All you had to do was label which transformation it was, take pictures of it. It's got 2 sides. Make sure you show both sides. Send it to me. I've got it probably from about half of you. Okay, that was a very easy worksheet. Easy points. So get that, send it in. Others of you, I'm still waiting for some of your quizzes. I'm sending out emails today reminding people what they still owe me so we can get it done. Some of you have already started sending me extra credit. If you haven't yet and you think you need to, that was supposed to be by tomorrow, the end of the day tomorrow. So if you know you need extra credit, send that to me. What, Pedro?
I think it's frozen.
Yeah, I think so too.
His Wi-Fi's been
All right.
bad.
I know mine just started cutting out on your all's class for some reason. So I know. So please, 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 I'm trying to go through, like I said, this afternoon, I'm working on trying to finish your all's class about telling you what you're missing. Because I did my 7th graders, I did my 8th graders. I've started working on you all and my 9th to get everybody caught up. So, because I was just going through like the order I have y'all in class. So I'm working on that today. So look for your messages in my schoolworks to see what I'm telling you you're missing, okay? See you tomorrow at what time?
11:15.
11:15, 11:15
11:20.
tomorrow.